Hey everyone, Assalamu alaikum. In today's lesson, we are going to discuss how to construct a critical path analysis. And since it is one of the topics that proves to be troublesome for most of the students out there appearing for Business 9609, let's have a go at this particular topic. So, I have a question that's relatively brief because I've saved a complicated one when I'll be explaining the concept of dummy activities, a concept that follows this topic. So let's start. So you can clearly see that there are 6 activities, namely A, B, C, D, E, F. Alright, and you're given the description. So first let me explain to you how do we go about it. For example, if you see this particular column, it is known as sequence, or in some cases it can also be termed as preceding activities. What does this particular column represent? Alright. For example, if you were to see activity A, it says that new designs are researched and prepared. And B goes on to say initial approval by directors. Now, if you apply common sense, you'll clearly know that it is impossible to get approval until and unless you are done researching and preparing your initial designs. Right? So B cannot happen until and unless A is done. B can only start once A is complete, and therefore the sequence clearly tells you so. Another example, if you look at C, costing of materials and labor. Now costing of materials and labor can only start, this stage can only start if you have gotten the approval from the directors. So in other words, in order for you to start activity C, you need to be done with activity B. Otherwise, it wouldn't be possible to start activity C. So this is how we interpret the column of sequence. And one last thing to note, that is right here. Now F can only start not at the end of D only, but also it requires E to be completed as well, because you can only produce samples once you have obtained materials for new designs and you have been done with the preparation of detailed drawings for production employees. Then only you can produce samples of the new design, right? So I would just give a tip that I usually give to all my students. Whenever in this particular column, even if it's termed as preceding activities or sequence, make sure to identify if there are more than one activity in this particular column. And if there are, then make a note alongside it and just write joint node. I'll be coming back to this concept as to why do we need to write. So let's start with the construction of CPA. So if you have studied CPA or read about it, you'll know that in CPA we make use of circles that are called nodes, and they represent information. What kind of information? Like for example, this particular section would tell you the node number. This particular section will tell you the earliest start time, and this particular section will tell you the latest finish time. I'll be looking at these terminologies in a while as soon as I progress with the construction of CPA. So whenever you're faced with the question of CPA, it is certain that you need to draw a first node. Before you start the CPA, there needs to be a first node. And many students, what they do is, if they see, for example, in this column of sequence, if they see multiple dashes, like for example here and here and here, I have also seen them to start off with 3 different circles. Do not do that. You only start from one node. Alright, you follow one node only. Irrespective of the number of initial activities, you will only start from a single node. Alright, so the first activity that we have is activity A, because it's represented by a dash and the duration is 12 weeks. So what do we do is, from this node we proceed with A and we write its duration just below the path. Alright, So one thing that you have to remember is that a node will never represent any activity. Many students would write activity like this. No, this is incorrect. An activity is always represented by the path that you draw alongside the node that you've drawn earlier. Alright? So we are done with activity A, and based on our previous discussion, activity B can only start once activity A is complete. So in order to complete activity A, we would need to draw a node again. So this is node number 1, this is node number 2, and we start off with activity B, and we clearly do the same thing that we did for activity A. So B is done as well. So we tick these two activities, and if you look at C also requires B to be completed. And if you look at D also requires B to be completed. This means that when B is done, you start off with two activities at once. So how would this go? How would this be shown in the CPA? You're going to make a circle to indicate that B has been completed, and then you're going to start off with activity C, and you give the duration 4. And then from the same node, you start off with activity D, and then you give a duration that is 2. So we are done with pretty much C and D. Now let's focus our attention towards E. E requires C to be completed. No problem. We complete C like this, and we stretch it out for activity E and write the duration. Now, one thing that I always tell my students in order for them to be more crystal clear with these concepts is that every node apart from the first and the last that I'm going to draw, every node, like for example in this case node number 2, node number 3, node number 4 that you've drawn, every node apart from the first and the last should show you two things. And what are these two things? They should show you an end of certain activities and the start of certain activity or activities. Now, if these two conditions meet, only then we can come to the conclusion that you have drawn a correct node. Now, what do I mean by that? For example, if you look at node number 2, right here, node number 2, this node number 2 would show you two things. Number 1, it basically indicates that activity A has ended because B has started, and B can only start once A is complete, right? So this node shows you A's end. But once A is complete, B starts. So this node also tells you that B has started as well. If you look at node number 3, what does node number 3 show you? That activity B has been completed and activity C and D have started. Likewise, if you look at node number 4, activity C has been completed and activity E that follows C has started, right? So up till now we are doing it totally right, because all of the middle nodes apart from the first and the last we haven't drawn as of yet, but every node apart from the first and the last are fulfilling these two conditions. So let's move on. Now, for the tricky part, activity F. Activity F tells you that I just do not need D to be completed, I need E to be completed alongside. And one of the blunders that students commit is, what they are going to do is, they are going to end D right here, and then end E right here, and then try to connect them, and then start off with F. Now, why is this incorrect? You remember the condition that I taught you. Every node should represent two things, the start of an activity and the end of another activity. So for example, if you look back at this node number 4, it shows you that C has ended and E has started. Alright? That's why it's the correct node, since it is meeting both the conditions, right? But if you look at this node, let's call it node number 5 for simplicity. If you look at node number 5, yes, it correctly tells you that E has ended. But what is this activity? If you were to say that this is F, Alright, then what is this? An activity cannot appear two times separately. And even if you say that this is F, this would mean that F will start when E is complete. But F says in the question that I will start when D and E both have been completed. So therefore, this activity is non-existent. This activity does not exist. And in the same manner, if you look at this node tells you that D has been completed. But what follows? You're blank because there is no activity. And since the node isn't meeting the two conditions that I mentioned earlier, that means that this node is incorrect. And this is the exact reason why at the very start of the video, I told you to make a note of the activities that are multiple in the sequence column and mention them with a joint node. Now, how do we go on about it since this is incorrect? So, sir, what's the correct way to connect these two activities and start off with F? Since it is a joint node, what you're going to do is you're going to connect them and then you're going to draw the commencement of activity F. Now, this node fulfills both conditions. This node shows that D and E have successfully ended and F has commenced. So it meets both the conditions and therefore it is a correct node. And finally, you are going to draw the last node, which shows the end of the entire project altogether. Alright, so this is pretty much the construction of CPA. Now, without further ado, let's go towards EST and LFT. The earliest start times and the latest finish times. I've written the rules for both EST and LFT that you can see in this particular section. So first we are going to start off with EST. And as mentioned earlier, EST is going to be written in the top right section of the node that we have drawn. So any activity, whether it's any project, whether it is in weeks or months or days or hours or minutes or seconds or whatever, it will always start with 0. So in this case, you can clearly see that I've written 0 here. Now the first rule is that for EST we start from the left to the right, which means that our starting point will be this and our ending point will be this. And as we go, we try to add our values. Okay, so I'll leave the third rule in the later part. Let's focus on calculating the ESTs. Alright, so what do ESTs mean in the first place? For example, let me give you a different example. Let's say you are preparing for your exams and the first activity is for you to revise the notes and prepare for the course. Alright, and let's say the time it takes you to do this is 3 hours. And the other activity is to practice past papers. And let's say the time that it takes you to practice past papers is 2 hours. And activity C is, let's say for example, you doing revision, and revision would take, let's say for example, 1 hour. Now the order is that A is the starting activity, B will follow A, and C will follow B. So B cannot start until and unless A is completed, and C cannot start until and unless B is completed. Alright? So far, so good. So let's say for example, you started off activity A at 2 p.m. So you started studying for your course at 2 p.m. And assuming that you're not taking any breaks, and this is an ideal standard, so activity A will take 3 hours itself. So by the time you get done with activity A, the time would be 5 p.m., right? So if I were to ask you, can you start off activity B at 4 p.m.? You cannot. At 3 p.m., you cannot. At 4:30 p.m., you cannot. Why? Because the activity that is needed for B to start hasn't finished till 5 p.m. So the earliest time B can start is after 3 hours or is after 5 p.m. You cannot start it before 5 p.m., right? So the earliest start time for activity B in this context is going to be after 3 hours. And if, let's say, for example, you start off with B at 5 p.m., by the time you end B, because it's 2 hours itself, by the time you end B, activity B, it's going to be 7 p.m., right? So if someone asks you, when are you going to start off with revision? What's the earliest time you can start off with revision? So you're going to tell them, I cannot start before 7 p.m. Do you get my point? This is the concept of earliest start time. Now coming back to the context of the question, if you can clearly see, you started off with A at 0 weeks and A takes 12 weeks and B can only start once A is complete. So therefore, if A started off at 0 weeks and A is taking 12 weeks itself, this means that the earliest time that B can start is after 12 weeks, right? And same goes for C, because C and D will only start once B is completed. And since B starts after 12 weeks and takes 1 week for itself, the earliest time after which C and D can start is after 13 weeks. So far, so good. So you're going to work towards filling the nodes, and then you're going to take a pause when you're faced with a joint node. What do we mean by a joint node? So all these paths that you can see, all right, let's say for example, if this is a node, this will be a path, right? So all these paths that you can see, they are being connected one way or the other to different nodes, right? As you can see that they are all being interconnected and show a particular path which ends in a node, right? So if you look at node number 5 and assuming that you're going from here till here, right? So if you look at node number 5, you can clearly see that there are two ways, two different routes to reach node number 5. So one route is that you take this way. So you start off with 13, then you add 2 and you get the answer 15. So this is one way, right? That is taking you a total of 15 weeks. And the other way is that you take 17 plus 5, that gives you an answer of 22. Now the question is, which value do I put here? And the rule says that whenever you're faced with a joint node, you consider the root with the highest answer. So by that, according to that rule, what I should write here should be 22. And why is 22 being written? Of all the reasons. Because if you, let's say for example, focus on the text of the question, activity F does not only requires D to be completed, it also requires E to be completed as well. And if you talk about 15 weeks in this case, after 15 weeks, yes, you will be done with D. If I talk about 15 weeks, so after 15 weeks, you will be done with D, but E will take a total of 22 weeks to be completed. And if you write 15 here, that would mean the activity F can start after 15 weeks, which is not correct, because activity F also requires activity E. And activity E takes a total of 22 weeks to be completed. So therefore, by this concept, we are going to mention 22 weeks and not 15, because by that time, both activities would have been completed, right? So 22 plus 2, we get the answer 24. Alright, so we are done with the earliest start times of all the nodes. And now, let's look at the latest finish times. The rules for latest finish times, all the rules that we just applied for ESTs will be reversed. So if we were working from left to right, here we'll be working from right to left. We'll be subtracting all the values as we proceed. And when faced with the joint node, we are going to consider the root with the smallest answer. So how do we start off with the LFTs? First of all, we are going to copy paste our answers from the last node, and now we are going to work back. So 24 in this case minus 2, and you will get the answer 22. 22 minus 5, you will get the answer 17. Now mind you, when you were calculating ESTs, if you remember, this node was the joint node because you have two paths coming to this node, right? But as you're going back, so you can clearly see that this node becomes a joint node for the LFT because you have two paths. One path is 17 minus 4, that gives you the answer 13, and the other path is 22 minus 2, that gives you the answer 20. So you're going to pick the smallest answer, which in this case would be 13. So you write 13, 13 minus 1 you write 12, and then 12 minus 12 you write 0. So this is pretty much, it looks very messy right now, but this is pretty much how you construct, fill and calculate the values in your critical path analysis. But the last thing that the examiner may also ask you, I have left floats and dummies for another lesson video. But for this video, one of the most important things, the summary, is that the examiner may ask you to identify something known as the critical path, and the examiner may also ask you to identify the minimum duration. So the minimum duration is perhaps the easier part because the value that you've calculated in the last node, that represents the minimum duration. And what does it mean? This means that this project will take at least 24 weeks to be completed, not any lesser than that. It may take more time, but not less than 24 weeks. 24 weeks is the bare minimum. Alright? So this is basically the answer of minimum duration. And what do I mean by critical path? So most students, when I am done with my entire calculation, most students tell me, sir, why are we going through this entire ordeal? Why do we not just simply add all the timings and get the answer directly? But if you do that, you are going to get the incorrect answer, that is 26. But the answer that we have calculated is 24. So what's the difference? The difference is that in order to calculate this 24, you did not consider all the values. Because when you were faced with a joint node, you had two roots, right? But you considered the root with the highest answer. And when you did this, you ultimately left a root. You ultimately left or let go of an activity. What do I mean? For example, if you were to see this 24 here, let's reverse and recalculate how did we get this 24 in the first place. So we got this 24 when we added 22 and 2 together, which means that this 2 was of vital importance, and therefore activity F was crucial and was important for us to calculate the value of 24. Alright, so how did we get 22 here? We got 22 here when we added 17 and 5. And since 5 belongs to E, another important activity that we have just received and that we have just figured out is activity E. So activity E helped us to calculate 22. But in order for activity E to help us calculate 22, we needed 17 here. How did we get 17 here? We got 17 when we added 13 and 4, which means that we used activity C for our calculation as well, making sure and indicating that C was important activity as well. And if you go further back, you got 13 here when you added 12 plus 1, which means that activity B was important as well. And lastly, you got 12 here. Once you added 0 and 12 together, which shows you that activity A was important as well. And it's the same thing. If you proceed from the ESTs as well. So how did you get 24 here? You got 24 here when you followed this path. You went from here. So you considered activity A, then you considered activity B, then you considered C and E to get onto this joint node, and then finally activity F. So this was the path, indicating that the activity you have foregone is activity D. And if you clearly see that the answer that we have obtained is 24, whereas if you add all the activities, you get an answer of 26, which is higher by 2. And what is this 2? This 2 is the duration of the activity that we have foregone, as you can see here. So this is how you calculate and determine the critical path. Let me know in the comments if you face any problem, and if you find this video helpful, please do not forget to subscribe so that I can put more videos for you. Thank you so much.